Good evening, everyone. Welcome to our Friday review session for your weekly dose of business analytics. How has everyone been doing for the past week?
Okay.
Oh, glad to know that. For this week, the homework is essentially on simple linear regression. The simple stands for that we have only one predictor in the regression model. What questions and difficulties have you encountered in homework 3? Yeah, so if you have not yet, I encourage you to bring up your homework writing and Excel file. So we can take a look at them together. As always, we can also refer to some of the review session notes I prepared. You will be able to find them in the review session page. You can find this by going to the Canvas course website, modules, and there is a tab on top for TA office hours. The review session link is right beneath here. So using this, you will be able to find the shared notes on Google Docs. So what are some questions you have encountered when doing simple regression homeworks? I think we have 3 or 4 homework questions.
Hi, this is Amna. I have a
Amna?
question about assignment 2. Is that okay?
Sure. Which part?
I had a difficult time creating bins for 3B for the homework last time. And I was wondering if you could show me how to create those in Excel.
Bins? Oh, wait. I'm
Like
not sure.
bins, you know,
On Mac.
yeah.
In Mac.
Okay, let me take a look at the question first. In question 2, as you mentioned, which part in question 2 did you have this problem from?
It was an assignment 2.
Oh.
Homework 2.
Oh, okay. Oh, I see. But we have a homework 3 due by Sunday, right?
Yeah, I just
Oh,
I wasn't
I
able to
see.
attend last time, so I was just wondering, just for like future.
Oh, for that, how about you watch the video I recorded for last week? You will be able to find the link here. I demonstrated how to create histograms.
Okay, sounds good. Thank you.
Yeah, and how to generate pivot tables.
Thanks.
That should be a good source. And as always, if you had questions regarding Excel operation, a good resource is already posted on the website. You can go to Google Doc and file. This directs you to a shared folder for Excel files. Particularly in this bootcamp, you'll be able to find 2 menus for Excel operation. It shows clearly how we can generate a pivot table. And it also includes instructions about how to generate regression models. However, for this time, let's focus on homework 3, where we need to practice linear regression models. Has any of you already done homework 3?
Hey, Jerry, I think one of my questions is interpreting R squared. So the language of it says that our model captures X amount and
Mhm.
percentage of variation
Yeah.
in the Y axis by knowing what the change in the X axis is.
Mhm.
But I feel like I'm parroting it and I don't quite understand what I'm saying when I say that. Can you explain more
Oh,
about
I
the
see.
meaning of that?
Okay, sure. Let's start with a simple example. In problem 1, I believe, we are trying to predict, problem 1. We are trying to predict house price based on square footage from 50 homes. So this 50 home is a sample we sampled in Orange County. So the original data is basically these 2 columns. I generated other information, so you won't see them if you downloaded this Excel sheet directly. But part of the question, I encourage you to start data analysis always from plotting. Although in problem 1, this plotting section is in the last part F. So when we interpret R squared, as Vivian has probably already generated in the summary output table from linear regression. And she has an excellent interpretation already, saying that this R squared 0.62 is telling us that 62% of variation in price, here is the price, that's the dependent variable we have in the model, can be explained by square footage. That's the independent variable we have in the model. However, she was not clear what it means. This percentage of variance explained or variance accounted for can be sensed by looking at a plot we make. So here, I'm plotting the price as the dependent variable on the y-axis and the square footage on the x-axis. So on this plot, this scatter plot, we see all the dots. Each dot represents one observation, that's one house out of the 50 houses we had in the sample. So this 62% is describing how much close are the points from or to the trend line. That's a linear straight line we have from the model. If all the points were exactly at the predicted line, then we would have a R squared equal exactly to 1. However, there are predicted errors that can be represented by the error term in the regression equation, because we have errors that represent the factors not accounted for. For example, there are many more factors that could determine or affect a house price, including the year a house was built. And in addition to square footage, it might be about the parcel lot size. It might be about the location of the house. If you're close to the city center, it might be more expensive. However, in our data, none of these additional factors were accounted for. So we have predicted errors. Because of the errors, not all variation in the price can be explained solely by square footage. That's why we see the points. Although they are somewhat close to the predicted line, there are still distances between the points as the observed price to the trend line as the predicted price. So R squared captures how far or how far away the points are from the trend line. If they're very close, then it's closer to 100%.
Jerry, in theory, if we had more data, not data, but aside from square footage, other variables to factor in, could it be assumed that our variance would go up, meaning that 62% would go up because we could explain more of the variation with more variables accounted for?
Yeah, you're basically right on that, but I detected you might have a incorrect interpretation of what variation refers to. So here, the percentage of variation explained for, right? That's what R squared stands for. Here, the variation stands for this, the total sum of squares. It means if we calculate this as a price, let me demonstrate. Price subtracted by the average price. So let me calculate an average. The average price of the 50 houses. So remember, when doing this, it's best to have the absolute reference so it doesn't change. Oh, okay. And we need to square it. That's what variance stands for, although these should not be formatted as dollar because it's square of dollar. So if we sum up these, then that's what it means by variation. The variation captures how price deviates from the mean price. So great question. That was from, was it Tilda?
Hey, Jerry.
I
It was
some other
me.
questions.
Thank you.
All right, excellent. Let me find the homework sheet. Meanwhile, did you encounter other questions? How about other students? Well, so in problem 1, in addition to a plot and interpretation of R squared, we also need to calculate a coefficient, correlation coefficient, and run a model, and then explain how well it fits the data, and also explain the effect of square footage on house price. Then we need to make some prediction before doing a scatter plot. Have you completed all of them? Any difficulties and unclear parts? We can also move on to problem 2.
Yeah, I have a question,
Okay.
Jerry. For the error or the residual, I didn't know where to find that. And that might be an obvious thing to find, but I didn't understand which number that was on the regression
Okay.
analysis.
For this homework, it doesn't seem that we need to answer anything about residues, but where did you find it helpful to generate residues?
Well, because when I was looking at the regression equation, it looked like one of the parts of the regression equation was the error or the residual.
Yeah.
So I thought I had to find that in the regression analysis, but I couldn't find it. I didn't know what to look for.
Oh, okay. So you could have generated the residues in the report, but it's optional option you can do. So, but you can actually calculate the residues yourself. How about we do that first? So In a regression output table, the default output is this part. It contains 3 sections: regression statistics, a ANOVA table, and a coefficient table. If you want to understand what each part represent, I encourage you to go to my review notes and use one of the resources I found. In week 3, simple regression, there's one blog, I believe, yes, about how to interpret each component of a regression summary output. In this blog explains clearly how each of the 3 parts in a Excel regression summary output table represents, starting from this regression statistics, ANOVA, and coefficient table. In the output table, the residue is reflected in 3 parts. There is a standard error that's related to the residue. There's also the residue sum of squares and mean sum of squares. But none of these need to be are required to address any part of our homework questions. But it's still very good to understand what it stands for. In terms of residues, it's reflected by the difference between the observed price and the predicted price. So as I wrote here as a tentative answer for the regression equation, this model in problem 1 is trying to predict price using square footage. So the price goes to the left-hand side of the equation as observed price, representing this column. And we place the coefficients and as intercepts and slope to make the equation complete. So the model tells us that we can predict the price out of an intercept plus the slope of the square footage times the square footage. So that's why it shows here. And the last question corresponds to the residue. Residues is also known as predicted error. So you can call either of them to this part. As I illustrated earlier, because square footage cannot capture all the information required to understand the price, so there's a difference between the observed price and the predicted price based on square footage. That's what the error stands for. And due to this model, we can calculate the predicted error using this equation by subtracting the predicted price from the observed price. So this is the observed price as what you had in the downloaded file. Now we need to generate a predict price so we can calculate their difference. This predict price is useful to address the second but last part of the question. In part E, we need to predict the price for some new houses, right? So let's do that. This predict price is nothing but a linear combination of the size or square footage. That's exactly what the model does, predicting the price based on square footage alone. So to generate the predicted price, we need to first include the intercept. That's this part. Intercept plus the slope or the coefficient for size, that's this part, times the size, that's this part. So that's how we can calculate a predicted price in a simple linear regression model. Then using this formula, we can generate all the predicted price. Any questions so far? Did you find it straightforward to generate predicted price using square footage. All right. Once we have the predicted price, now it's very straightforward to have the predicted error or the residues. As I indicated earlier, it's simply the difference between the price and the predicted price. Remember, because we are having the predicted errors on the right-hand side of the model, we need to subtract in the right sequence. So we need to subtract predicted price from the price, or we use price minus predicted price. Do not switch how you generate the predicted error. Otherwise, you could have a different sign for the predicted error. So this is how we can derive the residues. You could possibly let Excel generate the residues directly for you, but as I demonstrated just now, that's the way how the residues were calculated. Well, excellent. Have you completed problem 2? Did you encounter any questions? In problem 2, we are trying to predict the percent change, well, the fractional change of the Microsoft stock price using the general market stock price index. And as always, we need to explain the coefficient and R squared. All right. So how about we practice what how we should interpret a coefficient. Here in problem 2, one of the questions is what the slope of the regression line. What does the slope mean? Can one of you provide tentative answers, and we can start a discussion from there.
Yeah, I can take a crack at it.
Okay, great.
So the slope in this case says that for every 1% an increase in the x-axis, your y-axis will go up by that beta amount, according to that model.
Okay. Could you be more specific in terms of what the axis stands for and how much would go up?
Sure. So in my case here, my beta was a 0.94. So for every 1% increase in the x-axis, which is the S&P 500, Microsoft, which is the dependent variable, will go up by 0.95, according to the model that I generated. And so what that means is that the slope says that Microsoft, for the most part, aligns with the market, but it is going to be less risky than the stock market because it is 0.95.
Well, excellent. Was that Vivian?
Yeah.
Yeah, sounds brilliant. The answer, well, to interpret a slope, it's always best to put it in context. By substituting for what x and y axis are by its substantive meaning. So as I put it in my notes about how a slope should be interpreted, okay, these are some tentative structures how we can interpret regression coefficients. As we just demonstrated, it's always good to interpret using both quantitative and qualitative statements. Specifically, we need to supply some magnitudes plus the directions of the effects so that our interpretations are strong and specific. And we should also apply units of measurements correctly. So specifically, the interpretation should address this question: does increasing X increase or decrease Y? And by how much, in what unit, and relative to what group? So that a good candidate interpretation has such a format, using the example we just had about the price change relationship between Microsoft and S&P stock price. We could substitute here, given the estimated slope of, for example, 0.95, the expected change in the S&P stock price would increase. Oh, sorry. The expected stock price of Microsoft would increase by 0.95% for every 1% increase in the S&P stock price. So this would complete an interpretation in this case. However, if we are doing some group comparison, that's how we can do so, using the following example. So all of these would be much stronger and more specific than if we just said, oh, with an increase in S&P stock price, Microsoft price would also increase. This is not incorrect, but it supplies not as much information as what we need when interpreting a slope. We should give it a quantitative magnitude. Any questions regarding coefficient interpretation? Well, if not, I had a somewhat small challenge for you. How would you interpret the intercept in problem 1? That's about 64,000. Any tentative questions? I mean, any tentative answers? How would you interpret the intercept in question 1?
So for this one, according to the model, if the square footage is 0, so if there's no square footage at all, it would cost that much, 640K.
Well, exactly. That was a very great answer. The intercept exactly means what the predicted dependent variable, in this case, the price, would be if all the predictors are 0 exactly. So in problem 1, the intercept would mean that if a house has 0 square foot, then the predicted price would be $64,000. So as you can see, the intercept may not always carry a meaningful interpretation. If there was no 0 size in a house, then it's not a house, right? So that's why the intercept may not really have a meaningful interpretation. However, this doesn't mean that we should not include the intercept. The intercept is always required for a linear regression model. It's useful when doing prediction. If we remove the intercept, the predicted house price would be wrong. And in the Microsoft case, in problem 2, the intercept here means that if the general market S&P change would be 0, so the stock price for S&P stays the same, then it says that Microsoft stock price would the change, the increase, the percentage increase of Microsoft stock price would be 0.01%. So it may not carry a meaningful interpretation in this case either. However, this is still, the intercept is still required for making the correct prediction of percent change of Microsoft stock price. Was it clear? All right. It seems you're pretty good in model, in simple linear regression model. Did you have any questions regarding problem 3? It's about similarity measures. Particularly, 2 measures we're trying to use are matching coefficient and Jacquard's coefficient.
Hey, Jerry, I had a question on the Jacquard's coefficient part of it. So by changing the values to 1s and 0s, I ended up getting a value I didn't expect, but that was because I've set my yeses as 1s and my nos as 0s.
Sounds good.
And I guess the question is, could I have set my nos as 1s? So like my yeses as 1s and my nos as 1s, since they're different categories, or is that not a thing?
You could, but it depends on how much it describes the similarity. So if you believe when 2 people answer yes to a question, doesn't mean that they are similar. Instead, if they answer no to a question, means that they are similar, then you could assign 1s to no answers and assign 0 to yes answers. Was it clear?
I'm so sorry. I guess not yet. And I don't want to hold up the crowd. So
okay, how about you share your screen with us so I can understand how you address this question. So here, as Vivian pointed out, it's possible to code the answers in different ways, but usually it's a best practice to understand what we are doing before when we choose a specific approach.
hey, Jerry, sorry, can you enable share screen?
Oh, sure. It seems I do need to change the, I just enabled it.
Okay.
So the conventional option is that when, for example, when both people answered that yes, that they shopped with retailer before, we can code both answers as 1 and 1. And when, because neither drove a domestic car, so we code 0 for each of them. However, it's possible that we flip the 0 and 1 coding, but we need to have a good reason for doing so. Yeah, hi, Vivian. It seems I now see your shared screen. Do you also have your coding?
No, sorry, I have
okay.
that as like a scrap of paper, but essentially, in terms of what happened here, this would have been like 0, 1, Not a US citizen is a US citizen. 1 to 1, 0 to 0.
Yeah, it looks good to me. We can definitely do so.
So if I change this no to ones, now we're saying Jacquard's coefficient means that we're crossing out all the zeros. And that means we're only getting ones that match. So this would be 100% according to Jacquard if I did this.
Yeah, that's true.
And then so now when we talk about which of these coefficients would you use and why, I guess that would still lead us to the same ending, that matching coefficients is much better for us because it's closer to the true estimate.
Why did you believe so for C?
Yeah, so for C, I said that because we're looking at based on similarity. And just by looking at this, we see 2 out of the 4 items, 2 out of the 4 items Anne and Jill are matching on. But so we see that matching coefficient is 50%, which looks good. When we look at Jacquard's, we're seeing in this case it's 33, but in this case it's 100%, which is not exactly true. Anne and Jill are not 100% matching. So,
oh, I see. So basically here you're suggesting that the matching coefficient accounts for all the 4 variables, whereas the Jacquard's coefficient does not necessarily account for all the variables.
right, in terms of like the true match between the two.
Okay, yeah, that's a good interpretation. However, by true match, it's there can be different understanding of what a true match indicates. For example, in this case, if we coded drive a domestic car, no as 1, so it means that they both of them drive non-domestic cars, international brands, right? If you believe this indicates that they are similar, then this approach is valid. But if it doesn't, then it may not measure the similarities between these 2 people that well. So although some coefficient for similarity accounts for all variables, but it's another story that whether a variable actually captures similarity at all. If a variable doesn't capture similarity as what we intended it to be, to do, then using whichever matching coefficient may not address the question as well. So if driving a domestic car does not indicate similarity, for example, I drive Ford, whereas another person drives another US brand, but they're not the same brand. So we may have very different preference for car brands. Then if the underlying measure we wanted to address using similarity is that whether we have whether the customers have same car brand preference, then none of these 2 coefficients measure what we want. However, using the simple case, we do not have to go that far, right? We just assume that all these 4 variables exactly capture what we cared about similarity between 2 people. Then it's good to use these 4 variables.
Harry, can I ask a question regarding Vivian's data though? So Vivian, I hear what you're saying, but for shopped with retailer before, for an example, Jerry, she's measuring yes as 1, but then underneath she's measuring no as 1. I don't know that, like, if shouldn't it be like if yes is being measured as 1, it needs to be measured as 1 or as 0 for no?
Yes, you're right. We should do that. I mean, here, if we flip the sign for the assignment for domestic car, we should also flip the assignment in shopped with retailer.
Right, because I see what you're doing, Vivian, where you have like ones for both of them, but I think that you can't have them be the same and mean the same thing, if that makes sense.
No, I get you.
That's a
And
good
so by
point.
matching them here would cross these out. And then so that would give us a
That's true.
Jacquard coefficient of 0.33.
Mhm.
And then that kind of shows the matching coefficient is a little bit closer to these guys. But when there may be instances where this is kind of like one of those edge cases where it's like, this is possible, and Jacquard's coefficient would be not this guy right here. And so
if you flip the assignment for the fourth question, you should also flip the scores for the third one.
Yeah, I think that's what he's saying, Vivian. You can't just like, you can't make a no a 1. Like it has to be opposite. Even if I hear what you're saying, like if there's another type of variable or something,
So-
it has to be opposite of each other in terms of how you value the 1 and the 0. I don't know if that answers your question.
Yeah, yes, thank you. So here we are saying that if we code the yes and no's differently, we could have for the third question, shopped with retailer before, yes, as zeros. And in the fourth question, drive domestic car no as 1. So make sure we have consistent assignment of scores to yes and no.
Jerry, I have a question then, and maybe this will bring it full circle for Vivian. For C then, when deciding between which coefficient is more accurate, right, or which one we should use or we would use, it sounds like we really need to look at whether or not the variables that Jacquard is taking out, if they match on zeros, are binary, or whether they're not binary.
Yes, that's a good point. So how did you address part C?
I put that I would use Jacquard's coefficient because it's more accurate in depicting similarity between Anne and Joe, because they both don't drive a domestic car, but that's not a binary variable.
By binary, what did you mean? Why it was not a binary variable?
I guess I viewed it as just because they both don't drive a domestic car doesn't mean that they drive the same thing or use the same mode of transportation. Does that make sense?
Yeah, that's a very good point. So as we discussed earlier, always consider what it means when it answers when the subjects answer a question, whether it actually captures any similarity. So here, the student did not believe that drive or not drive domestic car measures any similarity. If none of them drives a domestic car, it could be because neither of them even drive cars. They may use other modes of transportation, or one of them drive a car, but it's not domestic. The other does not drive a car. So it doesn't really mean they are similar. That's why having this variable accounted for as what matching coefficient does may not be appropriate. Whereas Jacquard's coefficient, it does not include such this variable for driving domestic car or not. Then in this case, based on what we just discussed, it may be a good choice to use Jacquard's coefficient. However, you could also supply other reasons why matching coefficient could be a better option. All right, thank you, Vivian, for sharing your screen with us.
Okay, thanks for the explanation.
All right, we have additional, well, that's almost the end of our discussion session. I encourage you to look into our shared notes for week 3. I included some additional questions for practice. It's not required for your homework questions, but it's a good supplement. I also
Hey Jerry,
Hi.
it's Rachna here. I joined a little late. Can I quickly go over question 1 if you have time?
What part did you have question 1 about
So
question?
we just need to plot the regression, um, run the regression by using the Excel, right? For the first part.
Well,
What I meant
your
to ask
audio was
was,
cut off in the middle. So in question 1, we have 6 parts, right? Which of these did you have difficulty with?
so I think it's mostly, should we use the default Excel option to generate the regression, or do we need to change anything specific? So the
What part did
correlation
you,
coefficient,
yeah, which part did you want to generate that you thought it's
the
missing?
regression model.
Yeah. It's okay to use essentially the default options as long as you have everything that's needed. For example, you want to make sure that you have exactly 50 observations. Some of the
Okay.
options allows you to include or not include a variable heading or the variable name. So if you mistakenly change that option, you could end up with the number of observations like 49. Then it means that one of the observations is omitted. It may not be what we want. We also want to make sure that the intercept is included in the regression option, regression table or the window that's shown as whether to include a constant or not, I believe. Let me take a look. Go to data and data analysis. There's a regression part, right? And we just select regression. There's the regression choice window. So make sure that what should go into Y and what should go into
Dependent
X.
and independent. Okay.
So Y should be what we are trying to predict. That's the response.
Yeah.
I also included in my notes that the response variable can be named using many different aliases. It could be called the dependent variable, response variable, outcome variable, output variable, or the left-hand side variable. We just call it Y. I think that's simpler for the case in Excel. On the other hand, the predictors can be called independent variable or predictor, explanatory variable, regressor, input variable, or right-hand side variables, because we can have one or more predictors. In our case, in this week's example, we are using simple linear regression. That's why there's only one predictor in X. So make sure that both X and Y goes to the right place. If you flip X and Y, we can still have a regression model, but it's telling a different story. You can practice what happens if we flip X and Y when choosing the regression range for X and Y. So here, that's the cases we need to consider. Whether the variable has labels. If I well, here, because both columns has the top row as a variable name, so I can check whether it includes a label or not. Here, constant is 0. We should not use this because we want to supply an intercept. If we chose this, it tells the Excel program that the intercept must be 0. then it would be a wrong model. You could practice to see what happens if you check constant is 0. And you can predict price using the model following this, then see whether it gives the same model. And here, that's what I indicated earlier. You could let Excel generate the residues for you. And you could also generate all the other plots. We are not going into the other options.
Okay.
But you can practice. So when in doubt, as we discussed in our very first review, right? If you had any doubts, just try what each option could lead you to. Then make a decision to see, which of them is correct. So I'm going to generate another series of regression table on the same sheet. They will go.
Okay.
So as you can see, I generated another regression output, which exactly echo with what I had before. And here it gives us the predicted price and the residues. And you can check whether they match. And here they are exactly the same. As I said, that's how the predicted price and the residues were calculated.
Okay.
All right. So I encourage you to check each of the notes I made. Some of them would help you to determine whether you had a good answer for the homework questions. For plotting a scatter plot, for example, it's very good if we check whether it's plotted correctly. We could do so by checking the range of the x variable and the y variable. If they match with what's observed in our supplied data, then it's a good sign. If they don't match, for example, you could have flipped x and y when plotting the scatter plot. Then you could see that the horizontal axis represents the price. Then it doesn't really give us a good representation. Well, let's practice some questions about correlation. Then I will leave the rest of the practice questions to yourself. Could one of you tell me what a correlation coefficient equal to 0, 1, and -1 each imply?
So correlation coefficient of 1 means that the two variables have a dependency, like if one increases, the other one increases, something like that. And correlation coefficient is 0 means that they don't have a dependency. And negative means if one increases, the other one decreases.
Oh, that's a very good interpretation. It's not perfect because when this correlation coefficient goes to 1 and -1, it means a perfect linear relationship. So the linear part is very important because when data have some relationship, but it's not linear, that's when a simple correlation coefficient fails to capture the relationship. So for example, I included in my notes about this, what's known as the Anscope's quartet. There are 4 charts generated using very different data patterns, right? As you can see, each of the plot, as the orange points represent, they are very different relationship. Particularly in this second plot, we see that the x and y matches exactly to some curve, but the correlation coefficient fails to capture this. Each of them has exactly the same correlation coefficient, which equals to this much, 0.816. Each of them shares the same correlation coefficient. However, they provide us very different visual patterns. So that's why it's very important to plot the relationship instead of depending on some single value summary statistics like correlation coefficient. When correlation coefficient equals 0, it doesn't mean that x and y have absolutely no relationship, but it has no linear relationship or linear trend. When we plot the values for x and y, when we detect that the correlation coefficient is 0, it could be because of very different reasons. If x and y forms a circle, the correlation coefficient will be exactly 0. But it doesn't really mean that they do not have any relationship, right? But the correlation coefficient tells us that it has no linear trend or linear relationship. So that's what I meant by saying that correlation coefficient has certain limits or limitations. And I also encourage you to check some correlation coefficient. In simple linear regression, what's the correlation between x and y and predicted predicted y and x, and y and predicted x? We could also check the correlation between x and residues, and also y and residues, as well as predicted y and residues. And I demonstrated in my case, if we calculate the correlation between square footage and price, we see that the correlation is 0.79, which exactly matches with what the linear regression summary output table shows in multiple R. If we calculate a correlation coefficient between price and predicted price, the same correlation emerges again. This is because the predicted price contains essentially the same information as the square footage, because predicted price was calculated as a linear combination of a square footage. The predicted price only depends on square footage. That's why when we using predicted price to predict the price, is essentially doing the same thing as using square footage to predict the price. We can also calculate the correlation between residues and some of the statistics we had before. Oh, so F4 would assign absolute reference to the range. So let's calculate in for part 4, x and residues. All right. As you can see here, it's essentially 0. This e means it's 10 raised to the negative 16th power. So it's very close to 0. This is as expected. When we construct a linear regression model, the algorithm tries to minimize the predicted error in its squared sum. So if this would lead to that the correlation between x and the residue to exactly 0. Because of this, we will also find that the correlation between residue and let's see, let's try column B first as part 5, right? Y and residue. Let's find out. So as you can see here, the correlation between Y, observed price, and residue is not exactly 0. And when we calculate the correlation between predicted Y and the residue, I would expect that to be exactly 0 or nearly 0. So we calculate predicted error and predicted price. The correlation would be exactly the same as when we calculated the correlation between predicted residue and observed square footage. This is because the correlation between square footage and the predicted price is exactly 1. So that's square footage. Then this is predicted price. As you can see, this is exactly 1. It's not because of any rounding issues. This is expected because the predicted price is built solely on the linear combination of size. So they lie exactly on the trend line. That's why correlation is exactly 1. I would leave the rest of the questions for you to practice. They could be helpful to address some of your questions regarding linear regression and help you check whether your answers to homework 3 are correct. All right, this would summarize as our week 3 discussion. Any questions?
Hey, Jerry, this is T. I joined a little bit late. I sent you a message. I was just wondering when this would be uploaded to Canvas, the recording.
Oh, once I can download it, you will be able to find it.
Okay. Do you know if that's
tonight?
Oh.
In about 2 or 3 hours.
Oh, okay, got it. I don't know if it was going to take like a couple days. Okay, thanks.
Yeah, in the beginning, we discussed some part of question 1.
Yeah, right. Thank you.
Yeah, how about Lashanda? And there's another student that has a name that I have not seen before. So I don't know how to pronounce it. Are you all good?
Yeah.
All right. Glad to hear
Yes,
that.
I'm good, thank you.
Thanks,
Okay.
Jerry.
Then have a great night.
Thank you,
I hope to
Jerry.
see you again next week.
This
See you
was
next week.
helpful. Thank you.
Thank you.
Bye.
Have a great weekend.
You too, Jerry. Bye.